Welcome to my channel Mathematics Made Easy by Mary MJ. Today we are discussing class 11 chapter 5 complex numbers and quadratic equations. We are continuing the chapter. In the last class we discussed about I and I told that I is equal to root of minus 1. Now we will study about powers of I. Powers of I. So, if I is equal to root of minus 1, how much will be root I square? What will be I square? I square means it is I into I. And I it is root of minus 1 into again I it is root of minus 1. Root of minus 1 into root of minus 1 is minus 1. So, I square is the same as minus 1. What will be I cube? I cube is equal to I square into I. Already we know what is I square. I square is minus 1 into I and that is equal to minus I. How much will be I raised to 4? I raised to 4 means it is I square into I square. I square we have already found it here, it is minus 1 again into minus 1 which is equal to 1. So, using this we can find out. So, we understood that I raised to 4, the power of I raised to 4 that is equal to 1. What will be I raised to 8? I raised to 8 means it is I raised to 4 square. I raised to 4 already we know it is 1. So, 1 square and it is again equal to 1 itself. So, we can say that I raised to 4 raised to any power will be 1. So, in general what can we write? I raised to 4k will be equal to 1. That is, in terms of powers of 4 we can write it as 1. So, I raised to 4k, that is if I am giving values for k equal to 1, it is I raised to 4. So, I raised to 4 is 1. I raised to 4 into 2, that is I raised to 8, that also is 1. Then I raised to 4 into 3, that is I raised to 12, that also will be 1. So, I raised to powers of 4 will be always 1. So, how much will be? So, I raised to 4k we got it as 1. So, how much will be I raised to 4k plus 1? I raised to 4k plus 1 means it is I raised to 4k into I. And I raised to 4k is 1. So, 1 into I which is equal to I. So, I raised to 4k plus 1 is equal to I. Then, what will be I raised to 4k plus 2? I raised to 4k plus 2 and I raised to 4k plus 2 means I raised to 4k into I square. So, I raised to 4k is 1 and I square is minus 1. Same way what will be I raised to 4k plus 3? I raised to 4k plus 3 is I raised to 4k into I raised to 3. I raised to 4k is 1 and I raised to 3. I raised to 3 already we have found here. I raised to 3 is I square into I and I square is minus 1. Minus 1 into I is minus I. So, this also will be minus I. So, I raised to 4k is 1. I raised to 4k plus 1 is equal to I. Then I raised to 4k plus 2 is equal to minus 1 and I raised to 4k plus 3 is equal to minus I. So, these are the powers of I. Now, some identities. We are studying some identities for complex numbers. If Z1 and Z2 are complex numbers, let Z1 and Z2 be two complex numbers. Then Z1 plus Z2 whole square. What is Z1 plus Z2 whole square? Z1 plus Z2 whole square, according to our expansion, it is Z1 square plus 2 times Z1 into Z2 plus Z2 square. So as our identity is same thing only condition is that Z1 and Z2 are complex numbers. Then same way, what will be Z1 minus Z2 whole square? That is Z1 square minus 2 Z1 Z2 plus Z2 square. What is Z1 plus Z2 whole cube? Z1 plus Z2 whole cube is Z1 cube plus 3 Z1 square Z2 plus 3 Z1 Z2 square plus Z2 cube. Then what about Z1 minus Z2 whole cube? That is Z1 cube minus 3 Z1 square Z2 plus 3 Z1 Z2 square minus Z2 cube. Then how much is Z1 square minus Z2 square? That is a plus b into a minus b is a square minus b square. So Z1 square minus Z2 square is the same as Z1 minus Z2 into Z1 plus Z2. So these all identities you have to go through because problems will be there where we have to apply these identities. Okay. So let us move on to few questions. Express the following in the form of a plus ib. So we have to write the following in the form of a plus ib. First question, minus 5i into 1 by 8i. So this can be written as minus 5 into 1 by 8, minus 5 by 8, I into I is I square, and I square value we know that it is minus 1. So minus 5 by 8 into minus 1, which is equal to plus 5 by 8, and since we have to write in the form of the complex number, we can write the answer as 5 by 8 plus I0. Then second one, minus I into 2i into minus 1 by 8i whole cube. So here this is minus I into 2i is minus 2i square. Then into minus 1 whole cube is minus 1 itself, because minus 1 whole cube is minus 1. Then next is I cube into 1 by 8 cube, and that is equal to minus into minus is plus, 2 minus then plus, then I square is again minus 1, then I cube is minus I, and 1 by 8 cube is 1 by 8 cube, 8 cube means we can write it as 8 into 8 into 8. And here 1 2 is also there, 1 2 is here that we have to write in the numerator. So that can be simplified, so it becomes positive because both negative terms getting cancelled, positive. So 1 2 can be cancelled here 4 times, then plus I divided by 8 into 8 64, 64 into 4 256. So we have to write in the complex number form, that is 0 plus I into 1 by 256. Then next one, express 5 minus 3i whole cube in the form a plus ib. So earlier we studied the identities, that is if we are using a minus b whole cube, what is the expansion? A cube minus 3a square b plus 3ab square minus b cube. So expanding 5 minus 3i whole cube can be written as 5 cube minus 3 into 5 square into 3i plus 3 into 5 into 3i whole square, then minus 3i whole cube. That's equal to 125. Then here minus 25 into 9, 125 I. Then here minus 135 because I square is minus 1. So 135. Then 9 into 15 is 135. Then last term minus of minus, then 3 cube is 27. Then I cube is minus I. So here plus I. And that is equal to 125 minus 135 is minus 10. Then minus 125 plus 27 is minus, here 125, not 125, it is 225. Minus 225 plus 27 is minus 198i. So that is answer. Then next one, that's question number 4. Express minus root 3 plus root of minus 2 into 2 root 3 minus I in the form a plus ib. So we have to open the bracket, first term into first term, that is minus root 3 into 2 root 3, then first term into second term plus root 3i, first second term into first term, that is plus root of minus 2 into 2 root 3. Then next last into last, second term into second term, that is plus root of minus 2 into I. So here 2 root 3 into root 3, 3 into 2 is 6, so minus 6. Then second term is plus root 3i. Then this is root 2 into root of minus 1 or root 2i. So root 2 into 2 is 2 root 2, 2 root 2 into root 3 is plus 2 root 6i. Then last term minus root 2 into I square, because what is root of minus 2? Root of minus 2 is root 2 into I, because root of minus 1 into root 2 gives root of minus 2. So that means here it is, instead of this what can you write? Root of minus 1 into 2, which is the same as root of minus 1 into root of 2, that is equal to root 2i. So last term is root 2i. Now you can simplify this and write, where all I terms are there, here it is I square. So where all I terms are there, we have to write it together. Where all constant terms are there, real and imaginary, we have to split and write. So that is minus 6 and the last term is I square. I square is minus 1. So minus of minus is plus root 2. And here plus I into root 3 plus 2 root of 6. So now the real part is this one and the imaginary part is the second part. Now the next topic in this which we have to study is modulus and conjugate. The modulus and the conjugate of a complex number. So let the complex number be z is equal to a plus ib. It's a complex number. Then modulus of z we denote it as mod z, and mod z is root of a square plus b square, where a and b, a is the real part, b is the imaginary part. We call mod z as root of a square plus b square. And what is conjugate? Z conjugate. Z conjugate, conjugate of z, that is a minus ib. So conjugate of z we call it as z conjugate, and that is conjugate of a plus ib is a minus ib. Modulus of z is root of a square plus b square. Then next we have to study is what is the multiplicative inverse, and we denote it by z inverse, multiplicative inverse. And multiplicative inverse we have already studied earlier. Then also once again I will tell, z inverse means that is 1 by z, and here we have taken z as a plus ib. In a complex number, it will not come, the denominator will not be having real part and imaginary part. So what we have to do is we have to write this complete complex number form. For that we have to multiply by its conjugate in the numerator and denominator, that is a minus b in the numerator and in the denominator we have to multiply, so that the numerator becomes a minus ib divided by a plus b into a minus b is a square minus b square. So a plus ib into a minus ib is a square minus I square b square. That is equal to a minus ib divided by a square minus minus 1, that is plus a square plus b square, and a square plus b square, mod z is root of a square plus b square. So what will be mod z square? It is a square plus b square. So we can write this as a minus ib is z conjugate divided by mod z square. So z inverse is equal to z conjugate divided by mod z square. So that is the multiplicative inverse. So in order to find out the multiplicative inverse, the formula is z inverse equal to z conjugate divided by mod z square. That is the multiplicative inverse of a complex number. So suppose we are taking the complex number 2 minus 3i. How can you find out the multiplicative inverse? Let this be z. So multiplicative inverse is z inverse is equal to z conjugate by mod z square, and that can be written as 2 instead of 2 minus 3i we have to write 2 plus 3i divided by 2 square plus 3 square. That's equal to 2 plus 3i divided by 9 plus 4, that is 13. We can split and write, that is 2 by 13 plus I into 3 by 13. That is to find the multiplicative inverse. Okay. Now for any complex numbers, for any two complex numbers z1 and z2, modulus of z1 into z2 is the same as mod z1 into mod z2. Okay. For any two complex numbers, mod z1 into z2 is the same as mod z1 into mod z2. Same way, mod z1 divided by z2 is the same as mod z1 divided by mod z2. And third one, z1 z2 conjugate is the same as z1 conjugate into z2 conjugate. Then fourth one, z1 plus or minus z2 whole conjugate is the same as z1 conjugate plus or minus z2 conjugate. Then one more, z1 by z2 whole conjugate is the same as z1 conjugate divided by z2 conjugate, where z2 is not equal to 0. These are few of the properties which we have to study, that is modulus of z1 z2 is the same as mod z1 into mod z2. Modulus of z1 by z2 is the same as mod z1 by mod z2. z1 z2 whole conjugate is the same as z1 conjugate into z2 conjugate. z1 plus or minus z2 whole conjugate is z1 conjugate plus or minus z2 conjugate, or z1 conjugate, z1 by z2 whole conjugate is the same as z1 conjugate by z2 conjugate. Now next question, express the following in the a plus ib form. Express the following in the form a plus ib. In that first one, 5 plus root 2i divided by 1 minus root 2i. So, 5 plus root 2i divided by 1 minus root 2i, we have to multiply by the conjugate. So, 5 plus root 2i divide, here what we have, what is the conjugate of the denominator? So, 1 plus root 2i divided by 1 plus root 2i, and that is equal to, we have to multiply the numerator, 5 plus root 2i into 1 plus root 2i divided by a plus b into a minus b is a square minus b square. So, 1 square minus root 2i the whole square. We have to simplify this. 5 into 1 is 5 plus 5 root 2i plus root 2i plus root 2 into root 2 is 2i square whole divided by 1 square is 1 minus root 2 square is 2, I square is minus 1, so plus 2, and that is equal to, here I square is minus 1, so 5 minus 2 is 3, then plus 6 root 2i divided by 3, common terms, 3 is common in the numerator and denominator, so you are getting 1 plus 2 root 2 into I. One more question. I raised to minus 35. I raised to minus 35. So, we can write this 35 in terms of 4 because we know I raised to 4, powers of 4. So, this we can write it as 1 by I raised to 35, or this is equal to 1 by 34, I raised to 35. How can you write I raised to 35? I raised to 36 into I raised to minus 1, because I raised to 36 are all multiples of 4, or this can be written as 1 by I raised to 4 raised to 9 into I raised to minus 1, and that is equal to, I raised to 4 is 1, raised to 9 is also 1, and this is remaining 1 by I raised to minus 1, and I raised to minus 1 is the same as I raised to 1, or it is the same as I, and in order to write in the complex number form, it is 0 plus I. That's in the complex number form. So, in the next video, we will discuss the exercise 5.1. Thank you for watching my video. Those who haven't subscribed, please like, share and subscribe, and also click on the bell icon for more updates and notifications. Bye.